Hello, you're welcome to today's class, and I'll be teaching you laws of indices with examples. So we have 6 laws of indices. We have the multiplying indices, dividing indices, brackets with indices, power of 0, negative indices, and fractional indices. So I'll be teaching you all this in this video with solvable examples. So number 1, we are starting with the multiplying indices. These indices, when you multiply indices with the same base, you add the powers. The law is stated using this expression: x raised to power a times x raised to power b. So this is an example of a multiplying indices. This law states that when you see a multiplying indices like this with the same base, this is the base, the x is the base, what you need to do is to add the powers. So this is equal to x raised to power a plus b. So now example, we have 10 raised to power 2 times 10 raised to power 3. This is simply equals to 10 raised to power 2 plus 3, which is equal to 10 raised to power 5, and that's our answer. Another example is 4a raised to power 3. Here we have a coefficient of a multiplied by 7a raised to power 2. Here we have the base and a coefficient. So how do we solve this? We multiply this base 4 times 7, 4 times 7. Then we'll bring our coefficients times a raised to power 3. Remember, 3 times 2 is 3 plus 2. So this is equal to 4 times 7 will give us 28. A raised to power 3 plus 2 will give us a raised to power 5. And that's our answer. I hope you're following. So in this law, whenever you see a multiplying indices, all you have to do is to add the powers. So number 2 law is dividing indices, and this is expressed as a raised to power m divided by a raised to power n. When dividing indices like this with the same base, all you have to do is to subtract the powers, and this can be solved as a m minus n. So that is how you solve dividing indices. So for example, we have 21a raised to power 9, this is 9, divided by 7a raised to power 2. So how are we going to solve this? All you have to do is, we have a different base, as you can see, 21 divided by 7. So you divide these two bases. 21 divided by 7 will give us 3. A will be equals to 9 minus 2. We are subtracting the powers. So 9 minus 2 is 7. So therefore this is equal to 3a raised to power 7. And that's our answer. Another example we have here is x raised to power 3 divided by x raised to power minus 5. Here we have the same base, which is x. So this is x raised to power 3 minus 5. Remember, it's division. So we are subtracting. This is 3 minus 5. And this is equal to 3 minus 5. Minus times minus is plus. Minus times minus is plus. So this is 3 plus 5, which is x is raised to power 8. And that's our answer. Let's go back to the third law. So the third law is brackets with indices. Indices with brackets. So when you're solving indices with brackets, you make sure that the power outside the bracket is multiplied by the power inside the bracket. So this is simply equal to a m times n. So that is how you solve indices with brackets. So for example, we have 10 raised to power 2 raised to power 7. So using this law, this is equal to 10 raised to power 2 times 7, which is equal to 10 raised to power 14. And that's our answer. Another example we have here is h raised to power 4 minus 5 raised to power minus 5. This is equal to h 4 times minus 5. And this is equal to 4 times minus 5 will give us minus 20. So our answer is equal to h raised to minus 20. And that's our answer. And lastly, another example we have here is minus 4a raised to power minus 3 raised to power 2. As you can see, we have a coefficient here of a, and our power is a negative power. So this raised to power 2 means this times this twice, which is minus 4a raised to power minus 3 times minus 4a raised to power minus 3. This is what it means. So solving this, minus 4 times minus 4 is 16 times a raised to, remember multiplication, the law of multiplication means you have to add. So we are going to add our powers. A is equal to minus 3 plus minus 3. I hope you understand. Minus 4 times minus 4 is 16. Times this a, the coefficient, raised to power minus 3 plus, because they are powers, we have to add it according to the first law we solved, the multiplying indices. So this will be equal to 16a minus 3 plus minus 3 will give us minus 6. And that's our answer. And let's go back to the fourth law. So the fourth law of indices is the power of 0. Any number raised to the power of 0 is equal to 1. Any number apart from 0 raised to power 0 is 1. In indices, 0 raised to power 0 does not count. It means nothing. But any power that is greater than 0, that is raised to power 0, is equal to 1. So example, to solve this, 19 raised to power 0 is equal to 1. 12 coefficient a raised to power 0 is equal to 12. A raised to power 0 is 1. That is the law. So 12 times 1 is equal to 12. And that's your answer. I hope you understand. 12 with a coefficient of a raised to power 0 is equal to, remember this is 12 times a raised to power 0. So a raised to power 0 according to the law is 1. 1 times this 12 is equal to 12. So let's go back to the next law. And the fifth law is the negative indices, solving a negative indices. And this is how it is expressed. A raised to the power of minus n. When you see an expression of an indices like this, all you have to do is to make this power to become positive. And by how do you do that? 1 over, you flip your a downwards. You make it an inverse proportion. So this a raised to power minus m is equal to 1 raised to power a raised to power m. You can see there is no longer minus because of the 1 over we introduced. That means we have removed this, we have changed this minus sign to positive sign. So this is the law. So we have some examples here. 5 raised to power minus 2. This is equal to 1 over 5 raised to power 2. And which is equal to 1 over 5 raised to power 2 is 5 times 5, which is 25. So our answer is 1 over 25. Another example we have here is 2 with a coefficient a raised to power minus 3. Here you can see we have a coefficient. So this will be equal to solve it inversely, to be equal to 1 over 2a raised to power 3. 1 over 2a raised to power 3. And this is equal to 1 over 2 raised to power 3 is 8. That is 2 times 2 times 2 is 8. And a raised to power 3 is a3. Therefore our answer is equal to 1 over 8a raised to power 3. And the last law is the fractional indices. An index is a fraction. This is a fraction. A over B. X is the base raised to power A over B. So the law states that whenever you have something like this, you make the denominator as the root. This will now be equal to B square root of the base, which is X, raised to power A. You make the A your power, while you make the B your root. That is what the law states. When you have an expression like this in your indices, X raised to power A over B, you make the denominator your root, while you make the numerator your power. So for example, we have 8 raised to power 1 over 3. This is equal to, we make the 3, which is our denominator, the root, and raised to power 1, you know we cannot write raised to power 1, so this is how it will be. That is the cube root of 8. Cube root of 8 is equal to 2. 2 times 2 times 2 is 8. Another example we have is 27 raised to power 2 over 3. So this is equal to 3 root of 27 then raised to power 2. I hope you understand. This is what the law states. The denominator will be our root, the numerator will be our power. So this is cube root of 27 raised to power 2. Cube root of 27 is equal to 3. 3 raised to power 2 is equal to 9. And that's our answer. Thank you so much for watching, and I hope you understand now the law of indices with the examples and how to solve them. See you in our next class.